Welcome to class, guys. Why some of you didn't come last Thursday? Tamaya, did you see the mango? Have you checked the recording? Is everything okay so far? So what we covered so far now is about the first topic, okay, which is chapter 3, consumer behavior. I showed you what is Lagrangian multiplier method, and in the assignment, I asked you to do it with Lagrangian. So I'm gonna check your assignment later. But here, let's continue. Okay, I showed you Lagrangian method so actually it merges the utility and the budget into one equation, right? And then we differentiate 3 times. We solve it systematically. And then you will find exactly how much to buy and how happy you will be. Next one. How are we going to do the utility maximization? By using the MR's method, okay? Actually, there are 2 roads to the same destination. Lagrangian is the machine method. It always works, even for complicated problems. But the MRS method is the intuitive method, okay? It's faster for simple problems, and it shows you why the tangency condition works. Tangents, right? Both methods solve the same problem, okay? We want to maximize the utility. Okay, let me write it down. For the recording, I will no longer send you the link. Okay, if you want to see the recording, you just go to my YouTube channel, you will find it. Another thing is I want you guys to fill in your available date for midterm exam, okay? This is very important. If you don't fill it, I just assume that you are available at any time, okay? So I'm gonna pick for you. So you will find a Google Sheet, and then you enter your information through that form, okay? What is the problem here? So we want to maximize. We want to find x and y in order to maximize our utility. But here, the utility function is x power half, y power half, okay? I'm continuing with this question. I'm continuing with this question, okay? But here I'm gonna show you another method, which is MRS. Okay. We want to maximize, but it's subject to our budget constraint, price of x times x plus price of y times y equal m. For the MRS method, so here we're going to use the MRS. How many steps in Lagrangian? Do you still remember how many steps in Lagrangian? 4 steps, right? But here we have 3 steps. The first one, you just find the MRS. What is the MRS? Marginal rate of substitution. Okay, here is the MRS in terms of X to Y. So we have marginal utility you got from X and also marginal utility you got from Y. Okay, for your information, we're gonna have 3 Chinese students, but they are still in China right now because they don't have visa yet. They're in the process of applying for the visa. They are double degree program, okay? They're gonna join us maybe in August, but I'm gonna send you the link to them. So you may see them, I think 3 of them later in August. Okay, so after we, so here is the MRS, right? And let's find the marginal utility first. What is MUX here? It's we take curl U over curl X, right? You should be very familiar with it. So half times X power negative half, Y power half. This is MUX. And next one, what is MUY? So curl U over curl Y, which is the half times X power half, Y power negative half, okay? Because I want to find the MRS, so I just get MUX and then MUY, right? And then I compare them. So here we have, let me just copy it. This is MUX, right? And we have MUY here. Okay, and then let's cancel out something we can cancel out half. Actually, the same logic as Lagrangian here, right? So here equal Y over X, okay? This is the marginal MRS of XY. This is the first step, okay? We're gonna find MRS. And next step, we're gonna set the MRS equal the price ratio. Remember the price ratio, which is the tangency condition here, okay? Because MRS is the slope of the IC curve, but price ratio is the slope of the budget line. And then we set them equal. So here is the tangency point. Here is the tangency condition. So in this step, we don't need Lagrangian's machinery for this. We just use the economic logic directly, okay? At the optimal, your personal trade-off rate, which is MRS, must equal the market trade-off rate, which is the price ratio. One thing here, why the subtitle here is XY, not YX? Because MRS is the slope of the IC. And then we always have X at the vertical axis, okay? And X at the horizontal axis and Y at the vertical axis, right? So basically it means how many Y you would like to give up in order to get 1 extra unit of X, okay? That's why it's MRS XY, okay? Be careful about here. And then we find MRS, right? Here's the MRS, Y over X equal the price ratio. But here we don't know what is the exactly price here. So we just use price ratio itself, PX over PY. And then we cross multiply. Py times y equal px times x, right? And then we solve for y. This equation, have you seen this before? Let's make it star, question star. This question is exactly the same equation we got from Lagrange's first order conditions, right? This one. No coincidence because both methods encode the same economic conditions. This is the step 2, okay? You set the price ratio equal to the MRS. And next one, we substitute into the budget constraint. Substitute what? Substitute the equation star here into the budget constraint. What is our budget constraint? Px times x plus Py times y equal income. Okay, we substitute. Star. What is the star here? Star here is y, right? So basically, we substitute y here. And just replace y. So here we have a px mx plus py times px over py x. This is the y, right? Equal m. And then do the simple algebra, you will get px times x plus px times x equal m. Because here we can cancel out py, right? One is in numerator, another one is in denominator. Okay, the same solution here, 2px, x equal m. So x star equal m over 2px. This is our demand function for x, right? If we substitute that x star back into our star equation here. So right now we got x star, right? So I'm gonna substitute x star into this equation. We will get y star equal m over 2py. And then we plug in numbers, right? The same as before. Px equal 1, Py equal 2, income equal 100. So x star equal 50, y star equal 25. The same answer, okay, as Lagrangian. But here, you see, we only need 3 steps, okay? The first one, find MRS. Step 2, we set MRS equal the price ratio, and then we just solve it. We can get x star, y star, and then we plug in numbers. We will get the exactly same answer as Lagrangian. Okay, so here is the question. When should you use Lagrangian and when should you use the MRS method? Which one do you prefer? MRS, right? Because it's simple. I think in my assignment, I asked you guys to use Lagrangian to solve that question, but some of you didn't. You just used the MRS. Okay, next one, I'm gonna show you. I'm gonna compare Lagrangian method and MRS method, okay? So you will see it, what is the difference and what is the similarity, and when should you use which method? Okay, so let me continue. Need to draw a table here. Okay, so we have first method, which is Lagrangian. And then we have MRS method, right? For Lagrangian, what is the first step? Step 1, 2, 3. For Lagrangian, what is the first step? The first step, we will need to write the Lagrangian equation, right? And then we take the three partial derivatives. But for MRS, we compute marginal utility of X and marginal utility Y directly. And next step for Lagrangian, we said, I think I'd better finish Lagrangian first. Okay, so next step, we set first order conditions equal 0. And then we solve for lambda in both. Next step, we just combine equations, right? Combine equations, just like after we combine equation, we just substitute into our budget constraint. This is 4 steps for Lagrangian, but it's not really same as what I told you before. Here, I just want to summarize it, okay, and compare with MRS. So basically for here, we just solve the equations, right? We just solve the problems. Okay, so for MRS, after you compute MUX and MUY, you just set MRS equal the price ratio. And then you're gonna have, because as long as you set the MRS equal the price ratio, you're gonna get Y equal PX over PY times X. The same, and then you substitute into budget constraint. So I'm gonna copy this one. Okay, those are the different steps for Lagrangian and MRS. Okay, next one. What is the bonus output? What is the bonus output? So for Lagrangian, we have additional variable, which is lambda, right? So the bonus output for Lagrangian is that give you lambda. And how we explain lambda? Lambda is the marginal utility of income, right? But for MRS, it does not give you lambda directly. Okay, be careful about the difference. For Lagrangian, it gives you lambda, but not for MRS. So, based for which method? Okay, so for Lagrangian, it's best for complex problem, okay? Like you have multiple constraints. But for MRS, it's simple for two good problems. Like we have X and Y, right? And it's fast intuition. Okay, so for exams with simple to good Cobb-Douglas problems, the MRS method is faster. Fewer steps, less algebra. But if I ask you for the lambda, if the question asks you for marginal utility of income, which is lambda, or if there are more than two goods, but that is not for you guys, you need Lagrangian, okay? So which one do you prefer, Lagrangian and or MRS? MRS, yes, less algebra. Okay, let's continue. Okay, here's the homework. I think all of you done, but let me help you with this one because I asked you to use Lagrangian, right? So I'm gonna show you how to write the Lagrangian. Here we have utility function. Here is our objective function, right? And we have, according to the information here, what is Jen's budget constraint? Okay, so it's 100 times D plus 400 times F equal 4,000, right? This is the budget constraint, but we need to rewrite it into 4,000 minus 100D minus 400F equal 0. And then, okay, so the utility here is our objective. Remember, objective function first and then constraint later. Okay, this is our constraint. Okay, I'm gonna just show you how does the Lagrangian equation look like. So it's 10 df plus lambda times 4000 minus 100d minus 400f. Same here. The first part is our objective, the one that we want to maximize. And the second part is our constraint. Okay, and then times lambda. For this question, the utility function is easy, right? 10 times df. We don't have power like what I showed you before. So in the exam, if I ask you to use Lagrangian, you must show me the Lagrangian equation here. If you don't know how to solve it, at least you need to tell me. You need to write this correctly, okay? Again, objective function first, plus lambda times constraint, okay? I think you can solve this one, and next one we have here. So think about it. Can we use Lagrangian multiplier method with perfect substitutes and perfect complements? Please discuss with your friends. Let's have 3 minutes. What do you think? What do you think? Lagrangian multiplier, can we use it to solve perfect substitutes and perfect complements? Yes or no? Yes? No? I told you before, microeconomics is about optimization, right? As a consumer, we want to maximize our utility. We want to minimize our expenditure. As a producer, you want to maximize your profit. You want to minimize your cost, okay? You see, always maximize or minimize. So it's about optimization. So here, Lagrangian fails for both, but for different reasons, okay? Cannot use Lagrangian to solve. Why? Okay, so for perfect substitutes, and then we have perfect complements. The utility function, okay, this is utility function. For perfect substitutes, it's a straight line. That means the utility equal d plus f. Or x plus y, right? D and f here just means two kinds of goods, okay? Okay, D and F just in general means two goods. But for perfect complements, the utility function is a minimum function. Because it's complement, okay? You must consume it together. So we just find the minimum of D and F. And what is the shape of the IC? What is the shape of the indifference curve? So for perfect substitutes, it's a straight line. Right, it's a straight line. But for perfect complements, it looks like L-shaped. It's a kink. So what is the problem for Lagrangian if we use Lagrangian to solve it? For perfect substitutes, because it's a straight line, so there's no tangency exists, right? Instead, we solve perfect substitutes by corner solution. Still remember, we use corner solution. Okay, for perfect substitutes, because it's a straight line, so there's no tangency exist. Instead, we use corner solution. But for the kink, because it's L-shaped, right? Like this, like a L. So we have, it's not differentiable at the kink point, okay? Not differentiable at the kink. Okay, if we cannot solve those two by Lagrangian, how to solve it instead? For perfect substitutes, because they are substitutes, right? So we compare prices. And then you buy 100% of cheaper good. Remember perfect substitutes. Let me draw it. We have X and Y, two goods. And we have budget line. So the blue is the budget line. And the indifference curve, it's also a straight line here, right? And then in the textbook, it's a color solution. Okay, so this is the indifference curve for perfect substitutes, right? So basically here, you're gonna compare the price, and here we choose X, but we don't buy Y. Okay, so here is the corner solution. for perfect complements, how we solve it. So you set D equal F because they are perfect complements, right? So we set D equal F. D and F here just means two goods, okay? Two goods, or you can set X equal Y in general. You set X equal Y and then you plug into the budget line. Okay, so for perfect substitutes, the indifference curve is L-shaped. Okay, so here is the indifference curve, okay? So we've done for chapter 3, consumer behavior, but this is our first topic, okay? Let me help you summarize. Here, first, we learned consumer preference, right? Which is related to the indifference curve, right? Which is IC. Let me erase it. Okay, first we learned consumer preference, which is related to indifference curve, okay? What is the assumption? You guys have to review. And this is related to what does consumers like? And next one, we talk about the budget constraint, right? This is related to budget line. And the question about what can they afford? And then consumer choice means the optimal point. Or optimal solution. And this is the question, what do they actually choose? And then 3.4, the reviewed preference, right? So basically here just means that we can see your choice by looking at you instead of asking you, okay? We can observe that what did you really buy, and that the thing that you bought will review your preference. And next one, marginal utility and consumer choice. So here we talk about marginal utility of X, marginal utility of Y, and then we can get the MRS, right? Marginal rate of substitution, XY equals the marginal utility ratio. Then we learned Lagrangian, right? Actually, it's just like how to solve the optimal solution, right? Two methods, right? So we have Lagrangian, and also MRS method. This is about how to solve the optimal solutions. Okay, two methods, Lagrangian and MRS method. That's all about this chapter, okay, consumer behavior. I just post a quiz through Canvas, through Mango. Can you access to it? So I'm gonna stop the recording now. I'm done.